Last night, something invisible but deadly reached a threshold that hasn't been crossed in over 2 decades. NASA's Deep Space Monitoring Network registered readings that made scientists pause mid-sentence during their evening briefing. The Van Allen radiation belts, those twin rings of charged particles encircling our planet like invisible shields, are now fully saturated, loaded, primed. And according to space weather observer Stefan Burns, one more solar blast could trigger what he calls precipitation toward Earth's upper atmosphere. Welcome back. If you lived through the Apollo era, you remember when we first discovered these radiation belts and named them after James Van Allen. Back then, they were considered one of the most dangerous obstacles to reaching the moon. Your astronauts had to pass through them twice, once going up, once coming back down. What we're witnessing now is something those engineers never anticipated. These belts don't just sit there passively. They charge up like cosmic batteries, and right now, they're at maximum capacity for the first time since 2003. Let me show you what happened over the past 72 hours. On January 10th, a coronal mass ejection slammed into Earth's magnetic field. Solar wind speeds surged past 620 kilometers per second. That's over 1.3 million miles per hour. But speed alone doesn't tell the story. What mattered was the orientation. The interplanetary magnetic field tilted southward. When that happens, Earth's protective bubble opens like a zipper. Energy pours in. And on January 11th and 12th, geomagnetic storm levels reached G1. Aurora borealis lit up across Iceland, northern Scandinavia, Greenland, and northern Canada. Not faint green wisps, intense dancing curtains of light, red, purple, green. People in Scotland, at latitudes where auroras are rare, saw them 2 nights in a row. Now, you might be wondering, we've had solar storms before. Why does this particular event matter? Here's why. While we were watching those beautiful lights, something far more concerning was happening in the radiation belts above us. Each solar storm injects fresh energetic particles into those regions. Electrons, protons, charged ions, all trapped by Earth's magnetic field. Over the past 6 months, repeated storms have been loading more and more energy into the belts. The belts expand, contract, and occasionally dump their contents into our atmosphere. Usually gradually, but when they're fully charged, as they are now, the next major storm could force a sudden release. What would that look like? Let me take you back to May 2024. The sun unleashed the strongest geomagnetic storm since Halloween 2003. G5 level. Extreme. Those storms came from a single active region on the sun, cataloged as NOAA 13664, one of the most violent regions scientists have observed in decades. And here's the remarkable part. We just learned this week that European scientists tracked that region continuously for 3 months using 2 spacecraft simultaneously. The Solar Orbiter orbiting the sun itself, and Stereo, positioned at a different angle. Together, they watched this region rotate around the sun's far side, invisible to us on Earth, and documented how it built up energy, twisted, and eventually exploded. But let me tell you what happened on the ground during those May 2024 storms that didn't make the news. Modern agriculture, the kind that relies on GPS-guided tractors and satellite-controlled irrigation, failed across multiple continents. Farmers lost working days, crops weren't harvested on schedule, the economic losses ran into millions. Here's something even more unsettling. Railway signals, the automated systems that control whether trains can proceed, experienced interference. Some signals reportedly switched from red to green without authorization. As one researcher put it, that's really scary. These weren't theoretical risks. These were real-world failures during a storm that reached G5 intensity. The storm we just experienced was only G1. Imagine what a G5 event would do now, with the radiation belts already at capacity. You might remember February 2022. SpaceX launched 49 brand new Starlink satellites. 2 days later, solar activity increased unexpectedly. The upper atmosphere heated and expanded. SpaceX lost 38 of those 49 satellites. What's our warning system? Currently, we have about 15 to 30 minutes of advance notice when a coronal mass ejection is about to strike. That's barely enough time to put satellites into safe mode. The European Space Agency is developing a new mission called Vigil, specifically designed to improve space weather monitoring. But it won't launch until 25 years from now. Until then, we're watching the sun with instruments that were state-of-the-art 20 years ago. Here's what I want you to consider. The sun is approaching solar maximum, the peak of its 11-year activity cycle. We expect more storms, bigger storms, in the coming months. The radiation belts are already charged. The next major solar eruption could be the one that matters. So let me ask you this. Do you remember the Great Magnetic Storm of 1989? The one that knocked out Quebec's power grid for 9 hours in March? Were you affected? And here's the bigger question. With our modern dependence on satellites, GPS, and digital communication, are we more vulnerable now than we were back then, or are we better prepared? Write your thoughts in the comments. I'm genuinely curious what those of you who lived through previous solar cycles think about our current readiness. Until next time.